Hello, this is Frederick from Avassa with the Avassa for Industrial IoT demo. In this demo, we will deploy the HiveMQ for Edge, an MQTT broker, to the IoT Edge. At the Edge, we have sensors and we have an IoT application. In this case, it's an application that does temperature aggregation and anomaly detection. The IoT Edge application can also generate alerts into the Avassa system, which I will show you in the demo. The HiveMQ for Edge forwards data generated by the IoT application into a central location. In this case, I use Eclipse Mosquito to gather data from the IoT edges. Once the data is in Mosquito, it's forwarded into an InfluxDB, and from that InfluxDB, we can graph that data in Grafana, also shown in the demo. Let me describe what this looks like in the demo. There are two virtual sensors, Modbus sensor and MQTT sensor. These two virtual sensors are only used to generate demo data for the rest of the demo. Then you will see HiveMQ for sensors, which is the HiveMQ for Edge deployed at the IoT Edge. What we call the IoT application here is actually called anomaly detection in the demo. Please note that what we call an IoT system is called a site in the Avassa UI, which I will switch to now. Here you can see the control tower where I have a number of applications deployed. So this is the HiveMQ. I will just briefly show you what it looks like. This is a vanilla HiveMQ from Docker Hub. We also provide it with configuration. For example, this one instructs it to connect to a remote broker, the Eclipse Mosquito, and which topics to forward and so forth. It also talks to the Modbus application, the one you can see out here. So this is the configuration where HiveMQ goes to the Modbus sensor and picks up data from that one. So this one we kind of covered. It just exposes temperature data over Modbus. The MQTT sensor is a similar example app that publishes temperature data into the HiveMQ. Then we have the anomaly detection container. This is code that I wrote for the demo. So this one is basically talking to the HiveMQ. And it can also generate alerts if the temperature is below a certain threshold. So now it's set at 5 degrees, so it won't actually generate anything. But with all these applications up and running, if I switch to my Grafana here, you can actually see that I get temperature data. So in this case, I can see that this is MQTT data from the site called Home Cluster. And I also have like MQTT data from the site called RH site. So this is just to show how data can be fed from a sensor into HiveMQ, going into the Mosquito, and then you can put it into an Influx as I did, or some other time series database, and then plot that using Grafana. Going back into the control tower, let's make a change to this one. So I'm going to update the version, and then I'm going to tell the system to start generating alerts when the temperature goes below 19 degrees. So I'm going to submit this now. And once momentarily here, when it's up and running and start getting data again, we should see alerts being shown. And here we go. So this tells me that I've now had an alert in Avassa for a temperature low on home cluster. And this is just to show how you can use our APIs to generate custom alerts, some alert that makes sense for your application, and feed those alerts into the Avassa system. And that concludes the demo. Thank you very much.